Hey folks, problem number 1, it says the probability of flipping a fair coin and getting tails is 50%. So we're all familiar with flipping a coin, right? Tails, 50-50. You think your friend is cheating and tails is not coming up enough. You think the probability of tails with this coin is less than 50%. So basically you think your friend is cheating, right? If you flip a coin 1,000 times, you should get tails about 500, right? That seem reasonable? Exactly 500 would be kind of weird. 490, sure. 510, sure. At what point does it get weird? Like if someone flips a coin 1,000 times and they say tails only came up once, you would say, no, that's just not possible. But anything's possible, right? But why would you say that didn't happen? You would say, I don't believe you because the probability of that happening is just so low. There's no way you're that lucky. There's no way we just witnessed an extremely low probability event. Therefore, I think you're a liar. So that's the whole idea of hypothesis testing. So the null hypothesis is, let's assume something to be true. So in this problem, we're going to assume that it's a fair coin. The probability of getting tails is 50-50. So P is equal to 0.50. The alternative hypothesis, H1, HA in some books, is we think that the coin is coming up less than 50%. The wording of the problem is very important. Sometimes we think it's less, sometimes we think it's more, sometimes we think it's different. So in this one, it explicitly says we think it's less than 50. So P less than 0.50. Okay, so in our problem, we make our friend flip the coin 1,000 times, and they got tails 460 times. We were expecting, if you flip it 1,000 times, we're expecting about 500, right? Is 460 so low, so much below what we're expecting that we go, yeah, that probably didn't happen? We can actually kind of figure out exactly what the probability of that situation is, because flipping a coin is just a binomial situation, right? So let me bring over my fancy calculator. Let's see if I turn it on. So we're trying to figure out, it says come up with 460. I'm going to do 460 or fewer. Just go with that idea. So I'm just going to use a CDF. Hopefully we're all familiar with our binom CDF that we learned. So distribution, go to my binom CDF, enter. And then remember you have to give it an N, a P, and an X. So the N, we flip it 1,000 times. Whoops. R. Can I go back? Comma. That worked. Okay. 1,000 times. The probability is 0.550, comma. And because it's a CDF, let's just give it 460. So this is going to represent the probability of our friend getting 460 or fewer tails. And the probability of that is about 0.006. So I'm just going to write that down, 0.006. So using our 0.006. So we could have done the problem this way, but just go with this idea for a few. The probability of our friend flipping a coin 1,000 times and getting 460 or fewer tails is about 0.006. That's less than 1%. So I think our friend's a liar. I think that coin is unfair. Something weird's going on. 0.006 is a really small probability. Okay. So in our problem, it says, is there sufficient evidence at the 5% significance level, alpha 0.05? So that's our breaking point. Remember in previous homeworks, we said anything that happens with probability less than 0.05, we're going to call weird or unusual or unlikely. So that's that 5%. We could change that. That is our significance level. So it's the same thing here. They say our significance level is 5% or alpha 0.05. So that's our breaking point. In this problem, they're saying anything that happens with probability less than 0.05, we're going to say is weird or unlikely or unusual. So that's what alpha or significance level represents. Okay, test stat. So we have a test stat. Let me pause for 1 second.